Hi guys, welcome to Simple Programming. In our previous video, we looked at Spring Boot Cassandra example with auto configurations. In this video, let us go a little deep inside the concepts. In this example, we are going to look at how to use abstract Cassandra configuration class to configure uh, Spring Data Cassandra configurations using Java config. I've created a Cassandra config here. Let me open it up. So this Cassandra config extends the abstract Cassandra configuration class. What is this abstract Cassandra configuration class? This is a base class for Spring Data Cassandra configurations using Java config. In this example, I have custom properties for key space name, contact points, port, username, password, all mapped to member variables in this class. And then I have overridden a get key space name method from the abstract Cassandra configuration. And then I have also overridden a Cassandra mapping method. We are going to create a Cassandra cluster factory bean for our connection properties. This cluster object is then fed to the Cassandra mapping context along with the key space name. So this takes care of the persistence of the entities directly to the database objects. This abstract Cassandra configuration class has more than what is shown in this example. You can in fact create an entire schema directly from here. Let us try to look into this abstract Cassandra configuration file. This schema action method can make sure that if the schema is not present, then you can create one. Then accordingly, you can create key space specification construct and feed it into this schema action to create a new schema if a schema is not defined or if it is not created in the Cassandra database. This is a one way of doing. There are a lot of things in this particular abstract Cassandra configurations that you can take a look or you can research on that depending upon your needs. For this example, we are going to keep it very simple. And then what I've done is I have a model and an entity. The model is simple table, simple type. The entity objects are simple table entity and simple type entity, simple table primary key. You might be asking a question, why do we need two models with the same data elements? It is a good practice to segregate your actual request model and your entity model. The reason is, let us say, for an example, your project makes extensive use of JSON annotations. Let me try to add few annotations and so show you how complicated the model would become if you had just one model. Let me pick the simple table entity. What I'm going to do is I'm going to add few JSON annotations here. I'm going to add a JSON include here, and then I'm going to add a JSON root name. And what I'm going to do is, like, for example, here, let's say rate of JSON property access is going to be read only. Okay, I'll be doing a separate series on JSON annotations and how efficiently you can use, especially in RESTful APIs projects. So what I've done here is I've added an annotation at the rate of include, which is non-empty. That means, like, if your response has empty fields or null fields, right, those will be ignored. Those will not go out in the response. Then I have added a root name for my the model. Then I have added a JSON property. The access should be only read only. That means, like, this field is a response only field. If the user sends this field in a request, that will not be set in the setup. So you could see, right, how complicated this has become just for three annotations. Imagine if I'm going to add a lot of JSON annotations in this model, and I again have Cassandra annotations. How complicated this file would become. So this is the reason why we should have a separate model structure for your request model, and then a model entity model structure for your database objects. Let me try to delete these things and let's move on with our Cassandra example. Okay, all right. So in a previous example, we annotated all the Cassandra annotations here directly in the simple table and used it. But in this example, I have moved everything to an entity object and I'm using it. In this example, we are going to look at something called user defined type in Cassandra. For this, what I did is like I created a simple type object and I'm going to create an instance of the type object inside the simple table here. I also created a simple type entity object and I have annotated with it with user defined type equal to simple type, and I have a couple of columns in it. So what does this user defined type mean? So what does this user defined type means? It's like you can create a user defined type to attach multiple data fields to a column. Imagine like you want this entire simple entity elements to be stored in a single column, simple underscore type in the table simple table. So this is how you can achieve that. You have a user defined type. There are there are different types and available in Cassandra. We'll take a look at that when we do the Cassandra series. Okay. If I have to give you a better example, right? Let's say you have a student object. Address is a another object that has its own member elements in it, and you're going to create a student class. It has an ID, first name, last name, and address. The column address will have all the elements that are present inside the address. That is like the apartment number, street, city, zip code, all these things in in one column. I also did another thing here. I introduced something called at the rate of primary key. In our previous example, if you notice, right, I defined all my primary keys in the same model, but that's not good practice, right? So if you have a composite primary key, right, composite primary key is like two elements or multiple elements combining to become a primary key. It is a good practice defined by Cassandra to have it in a separate class. So this class is going to hold my primary keys, and this class is so I have created an instance in simple table entity for this class and annotated as primary key, so that Cassandra will know that this particular class is acting as a primary class for primary class, and it has all the IDs and different elements in it. Let's go on to the simple table primary key class. So we have this class here again. I have annotated it with at the rate of key primary key class just to show that this particular class is a primary key class for the Cassandra, and I moved everything else that we add in the simple table in our previous example right here. Pretty straightforward, right? Yeah. So there's one more change that I did in our Cassandra repository. I have added the simple table primary key as a as another type for the code repository. Earlier we had it. This is what we had in our previous example. So in this example, we changed it to simple table primary key so that Cassandra knows that primary key class available for this simple table entity, and Cassandra has to make use of it when it queries or inserts data into the database. Okay, all right. So apart from that, what I did is like I introduced a service layer. In a previous example, we didn't have a service layer because if you add a service layer just for passing the inputs from the controller to DAO, right, you are just that is a code smell in your application, because you don't want a middleman just to pass the information from controller to DAO layer. You can directly auto the DAO layer and use it. But in this case, in this example, there's going to be a lot of implementations in it. So I introduced a service package and a service class here. Let's quickly check what is present in this particular service class. So in this Cassandra service, I moved the Cassandra repository from the controller to the service. And what happens is like the controller is going to call the save into simple table, and we're going to save this simple table model into the Cassandra database. But there's a problem here. The simple table is not supported in the curl repository. The curl repository supports a simple table entity. So here comes up one more thing, like you have to map the object to entity here. So I have mapped the object to entity in the method, and then you have to again map the entity to the object in order to return it back to the end user. So apart from that, I also have a get mapping in my application. For that, I'm going to fetch the record. To fetch the record, here's the difference. In our previous example, we did we used find by ID and name, right? And we were passing the ID as a string and name as a string as two method parameters. So in this example, we are just going to create a primary key object. We're going to set these elements into the primary key object and send the direct. We are going to send the primary key object directly into the find by ID, and Cassandra will take care of understanding this and returning back a response for you. So here you can throw a better way to do this, like throw an exception when the data is not found, and catch this exception in the controller advice and return a an elegant response to the end user. That's how you have to do. Let's quickly go to the Cassandra controller. The Cassandra controller, pretty much all the code has been moved to service layers, so it doesn't have anything. It's going to get the request, and then it's going to call the Cassandra service layer. Same goes for the Cassandra mapping. It's going to get the path variables, and it's going to send these to the Cassandra service layer. Now let us move on to our database layer and see what are the changes done in the database. So in my Cassandra database, what I did is like I created a simple type. I created a simple type as a Cassandra user defined type, and then altered my simple table and added this simple type to this the Cassandra simple table. So after that, right, when I do a select query, so this is how the table look like. You can see the ID, name, creator time, and you can see the entire simple type object inside one column. So this is how user defined type works. This is pretty handy when mostly in RESTful API services. And let's go and now run the application, see how the response and request and response behaves in this case. Okay, so let's quickly run this example and see what is the response we are going to get. So this is my new request. I have an ID, name, and I have a simple type inside my request with the name as type name and type as user defined. I'm going to click on send and see what response I'm going to get. So I have received the response here. You could see that creator time is coming back. That means that creator time has successfully got inserted into the Cassandra database. Let's quickly open the Cassandra database and do a select query on that. Cool. Looks like our request has successfully got persisted into the database. Now let's fire a get mapping and see how the get mapping works. Okay, so looks like the get mapping is working totally fine. We are getting the actual response coming back. This means like the object, the model is getting converted to an entity object and it's getting persisted. And when you do a get mapping, the persisted object is again converted into a model and the response is returned to you. We did forget this particular property file configuration. Let me quickly open up this application.yaml and show you how my Cassandra custom property looks like. So this is my custom property. This is not a Spring Boot application properties defined example. So this is my custom property, and this property is directly used in the Cassandra config with the use of at the rate of value. Before we wrap this up, I want to quickly show you how to add multiple contact points in the configurations. So this can be done by going to the application contact. For example, let's say you have 10.12.1.1, and then you have 10.12.1.2, 10.12.1.3. Okay, these are three different nodes of my Cassandra databases. So I want to make sure that all these contact points are actually used by my Spring Boot application. So you can define this like this and directly send this inside the set contact points as it is. So you don't have to do anything else. This particular contact points can also be set in the when you do the auto configurations for Spring Boot Cassandra database, and this forms a cluster for your connection. Okay, so with this we come to the end of this particular video. I hope you really would have enjoyed this, and I hope this would be useful for you when you go and create a Spring Boot Cassandra application. In my next video, we are going to cover the most important topic in Spring, and it is the most sought topic in interviews that often confuses the candidates. Thanks for watching. Please subscribe for more videos.